Hello, my name is Brady Cecere, and I'm doing my experimental Latin square designs. So the Latin square design is used where the researcher desires to control the variation in an experiment that is related to rows and columns in their field. Latin square designs can be used for a lot of experiments, but one downfall that could be seen while using this design is that for the number of experiments, there must be double the experimental units. Using Latin square designs helps to control two sources of variation, and analysis is usually simple. So in the book, it gives us these three different examples of Latin square designs. There's a 3x3 square, 4x4, and a 5x5. You could have more like 6x6, etc. There's actually 12 3x3 line squares you could have, and as the number of different squares goes up, like from 3x3 to 4x4, the number of levels it will have. So it'll have more than 12 for the higher variations. So here's a table that you would get using Latin square designs. You could figure out the degrees of freedom, sum of squares, mean square, and the F statistic. So when you're finding degrees of freedom, you would do the rows -1. Columns would be the same, so this is a square. Treatments would also be r minus 1. The arrow would be r minus 1 times r minus 2, and the total degrees of freedom would be r squared minus 1. The sum of squares, I'll show how to find that in a minute. And the mean square would be the sum of squares for the rows divided by r minus 1. For the columns, would be the sum of squares of the columns divided by r minus 1. Treatments would be the same with r minus 1. But for the error, you do the sum of square error divided by r minus 1 and r minus 2. For the F statistic, you would do the mean square of r divided by the mean square of error, and etc. for columns and treatments the same way. So when you're looking at the sum of squares, you would use all these different equations for the treatments, rows, columns, error, and the total. So I'll show you an example of a 4x4 square that I figured out. So for the degrees of freedom, you would be 3 for the rows, 3 for the columns, 3 for the treatments, and error would be 6, and the total would be 15. So when you're doing the sum of squares using equations, you do the same thing as the following. So the mean square would be the sum of squares divided by 3 for all of them, besides the error would be divided by 6, as you can see, and the F statistic is also found. So this is a quick example of Latin square designs, and I hope it really helped. Thank you.